Okay, so this is a question from May June 2014, variant 61, question 2. Length of a certain type of white radish are normally distributed with mean mu cm and standard deviation sigma cm. 4% of these radishes are longer than 12 cm. So one information. 32% are longer than 9 cm. Second information. Find mu and sigma. So we need to use the first information, label the first, second. So make use of the first information, which is, that means probability that the radish, I make it as a variable x, it follows a normal distribution with mean mu, variance sigma squared. All right, so the x, the length of the radish, longer than, greater than 12 cm, and the probability is 0.04. Okay, so again, when you are given probability, you got to use the normal distribution table in reverse. And the first step is still standardization. 12 minus the mean over the standard deviation. So two informations, like I mentioned just now. One, greater than towards the right. Second information, less than 0.5. So when I'm going to sketch the bell-shaped curve, I will have an area that is towards the right-hand side and is a small area, a very small area, which gives you 0.04. Okay, so the z-score should be here. All right, but of course, when you want to read from the table, you are not able to do so because the table is constructed in such a way that it gives you the bigger area towards the left. Hence, we just take 1 minus 0.04, then we will get the big area 0.96. So in order to read the table in reverse, we got to find the probability 0.96 and get the corresponding z-score. All right. So let's see 0.96. I scroll down, and this is the extraction of the table. Look for 0.96. So we don't get 0.96 directly. We will get 0.9599. Okay. And then we just need to add 1. You will get 0.9599. Right. So the corresponding z-score, 1.75 and 1. Right. Remember, this column and this row will be the value of z-score. So the corresponding z-score is 1.751. Okay, that means I have managed to form an equation, which is 12 minus mu over sigma equals to 1.751. Okay, just have a quick sketch here. Means if you are going to get a smaller area towards the right with 0.04 probability, which is the area, then the corresponding z-score should be 1.751. And that's why these two values must be same. So we equal them, and that is how we get ourselves one equation. Okay, now we're going to do the same thing to form the second equation so that we get to solve them simultaneously at the end to find out the value of mu and sigma. So 32% are longer than 9 cm, longer than 9 cm, 0.32. So you can tell that this is the same like what we had just now. Okay, wait, let us standardize first. First, directions greater than to the right. Second, less than 0.5. All right. That means when we sketch the bell-shaped curve, it's the similar one, but this round it should have a bigger area because this area is 0.32. It has to be bigger than this. 0.32 should be more likely here. 0.32. Then the z-score should be 9 minus mu over sigma. All right. So we will do the same. We look for the bigger area here so that we get to read from the table in reverse. 1 minus 0.32, 0.68. Okay, now we look at the table and try to read the probability 0.68. Okay, 68. And here, right? This is the value slightly smaller than 0.68. So we still need to add. 772, right? So that means we need to add 28 in order to become 0.68. But you can tell here we do not have 28 exactly. So either we choose 25 or 29. And in this case, 29 is the closest value. So I will choose 29 because this is the closest value. Hence, the corresponding z-score 0.468. 0.468. Okay. 0.468. Okay. Right. That is why 9 minus mu over sigma equals to 0.468. Then we managed to get ourselves the second equation. All right, second equations. So now we have the first and second equations. We can solve them simultaneously. I will take the first minus the second. Right, 12 minus 9 is a 3. Minus mu minus mu become plus mu. So they will cancel off each other. Then 1.751 minus 0.468 will get 1.283 sigma. That is how we get the value of sigma. 3 divided by 1.283, I get 2.33826. So I'm taking 2.3383 and round off to 3 significant, 2.34. Then from the first equation, to find out the mu, 1.751, and we sub in the sigma value found, 2.3383. And finally, we get the value of mu. 7.9056. So this is the last value we need. We just round off to 3 significant 7.91. Okay, so we found the values of the mu and the sigma. by using the normal distribution table in reverse. Okay. So this is a similar question like what we discussed just now. All right, do try to answer these questions by referring to my examples before. Okay, so this is the question from May June 2013, variant 6.2, question 1. Right? That's all for this video about using the normal distribution table in reverse. Do subscribe to the channel and like this video. I see you in the next one. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.